Okay, here's what I wrote.
That works. All right, so I've got a video that I'm putting in the chat here. It's like 5 minutes. You can watch as much as you want of it, but it will help to explain Newton's three laws, and then I'll explain them for you as well. But if you'd like, you could watch the video. Might help to explain things. If not, we can just go right into the three laws, Newton's
We
three
can go into
laws.
the three laws.
Okay. So the other way to do it here is to have you um, well, I, it's only 5 minutes. Let's have you watch it. It really will help. I don't think I can explain it as well as this video, and then we'll just summarize them.
Um,
So go ahead and watch the video, and then we'll talk about the three laws.
okay. How long is the video, by the way?
5 minutes.
Okay.
All right. Are you almost done watching it?
Yeah, there's like a minute left.
Okay. It's up to you if you want to watch the rest.
I do want to watch the rest.
Okay. It was a decent video.
That was a very fast answer, wasn't it?
Yeah.
Okay, now it's done.
All right. So the first law is kind of the actually it's called first law. It's really two things. It says an object at rest will remain at rest. And you can think of it as like a book or a computer or a phone, whatever, something on the table. Like it's not going to move. It's not going to suddenly move. Uh, this doesn't move. The second thing is an object in motion will remain in motion. This one's a little bit harder because things that are in motion tend to not remain in motion. But in both cases, um, this is only so long as no external forces are applied. And that's the reason why you slow down when you're doing anything, because eventually there are other forces present. Is that clear?
Yeah,
Okay, the second law is F equals ma. That's it.
awesome.
So we've been doing a bunch of that. The third law, we've also been doing a lot of, it's that basically that forces come in pairs. There's always an equal and opposite force. Um, they don't there's not like a force out there that just totally un that doesn't have something countering it. Um, yeah, this is good versus evil kind of thing as well. Like so that's the three laws of motion. Any questions on that?
Nope.
All right, so that is done. We're going to now look at the lab. Very exciting. Okay. Here's the lab format that we've seen a lot of times. We need to answer some questions, and it's kind of a lot. So, all right, here we go. So it says, take a look at the graph of a ball in motion. So just to be clear, the ball is not like going down. This is the position of the ball. So it starts out at 5 meters, and think of it as being like 5 meters away from you. And then for, I'll say 3 seconds here. This looks like, probably draw a tick mark in. This looks like 3 seconds here. It's not doing anything. Ball's just at rest. It's not moving. It's just 5 meters away from you. Then the ball, and we'll call this 8, it's like 8 seconds. The ball is now where you are. Like you want to consider yourself home or you. I always like that analogy. Ball is coming at you. Maybe someone kicks it towards you, for example. Maybe you go grab the ball and come back to wherever you were. But we're only talking about the ball here. Is that clear?
Yeah.
Okay. So we now need to come up with some words that convey that. The ball starts 5 meters away. In the first 3 seconds, the ball isn't moving. Then the ball comes to you, returns back to the position, origin position, original position, home, wherever that is, and then it's at rest again. It's not moving. So there's kind of three parts to this that we're looking for. There's what's going on here in 1, 2, and 3. So therefore, think of it as 3 sentences. So so give me a sentence for and you can start it this way. In the first 3 seconds, tell me what is happening to the ball.
In the first 3 seconds, the ball is up in in the air.
Could be, but then something's
Yeah.
holding it in the air. I would just think of it as being 5 meters away from you, and probably on the ground is better than
Okay,
thinking
it's
of it
on the
as in the air.
ground.
If you could type something up to reflect that, that would be great.
So, for the you're saying like you want me to do a sentence for the first 3 seconds. I'm looking at the trick. Can't I just say for the first 3 seconds the ball hasn't moved and then it
Yes,
started making.
yes. That's all you have to say. We're going to write 3 sentences, one for the first 3 seconds, then for the next 5, then for the last 2 seconds.
All right, there we go.
Right. So more than that, though, yeah, you're right. It's not moving. Um, how far away is it?
Um, ooh, I don't know.
What is the position? What's the Y value there?
It is 0 because it's
Nope.
nowhere.
What's the Y value?
6? Sorry,
Yeah,
5. It says 5.
yeah, 5. So in the first 3 seconds, the ball is not moving and is 5 meters away.
Okay.
Okay. Now you've got to tell me what's going on in the next 5 seconds. So that's from this dot up here to down here, what happens to the ball? We know where it starts, it's 5 meters away, but then where does it end? What's the Y value here?
0.
0. So that means it's gone from being 5 meters away to now being 0 meters away, or, right backward,
Yeah.
think of it as being home or something like that. So could you put a sentence together again? I've already started it. You just say in the next 5 seconds and then dot, 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 you have to fill in what is going on there.
In the next 5 seconds, it's ascending, like going up.
Don't think of it as going up or down. Just think of it as it's some distance away. It was 5 meters away and now it's 0 meters away. Because it could be a ball on the ground that is moving towards you. Doesn't necessarily need to be in the air.
Okay, here's what I wrote. Can you tell me if it's correct?
Okay, so the ball is 5 meters away in 3 seconds. That's what the graph is showing us. So let me make it try to make it even clearer. At that point right there, the ball is 5 meters away.
Right.
Okay. And then 5 seconds later, ball is 0 meters away. Does what you wrote say that?
No.
Okay. It's just a sentence to say what you don't explain how, you just have to explain like start and finish. It was distance away, and now it's this distance away.
Okay. Does that say 0 miles away? Where the
Meters,
arrow is
meters.
0 meters away. So what I wrote right now is that in the next 5 seconds, the ball is getting farther away from, I don't know, 0 meters away. I don't know what to say.
Let me try it differently here. I'm gonna
Okay.
share this applet here. Okay. So all right, so I'm going to play this for 3 seconds, and I want you to watch the guy tell me what's going on with the guy. Okay.
Okay.
All right, what happened with the guy?
He moved for a little bit and then stopped.
He actually did not move. He's always at 5 meters away. I know he kind of adjusted his posture or whatever, but he actually didn't move.
Oh,
Okay, so that's what happened with the ball in the first 3 seconds. Did it move? Did the ball move? No. The
no.
guy did not move. Okay. Now watch what happens to the guy. Okay. And think of zero as your home. You're here. You're here at zero. He's 5 meters away. Watch what happens.
He moved to his home.
Yes. So that is what the ball did. That's what this line going down means.
So what I say that is that in the next 5 seconds the ball is moving to its targeted
You you can call it the
velocity.
home, origin, it doesn't matter, but you have to say something about it moving now 0 meters away. It was 5 meters away, now it's 0 meters away. The man was 5 meters away, now he's 0 meters away.
All right, I just wrote something in the chat that I think it will work.
You got to say where it started though. So I'll edit it here.
Okay.
Uh, in the next 5 seconds. So again, the ball, the ball moved it's always from and to, from being 5 meters away to uh to being 0 meters away. Is that okay?
Yeah. Um, I think your screen is stuck on the man moving right now.
Okay,
I think
let's go back to the other screen.
there we
All right.
go.
All right. So now in the last 2 seconds, is the ball moving?
No? No, yes, I'm sorry.
If it's moving, tell me where it started, which is zero, to where it ended. Here's where it ended.
So
Is
I the
is the
ball
is the is the ball moving?
no.
It is not moving. So I need a sentence that says in the next 2 seconds what you just said about the ball.
Right. I just typed it out.
Okay, that's good. All right, good job. I know that was challenging. Did pretty well. I think the issue is that you want to think of it as like vertical height, which it may or may not always be. So okay. Um, so there's another graph here. So the teacher's really trying hard here to help you answer this. They're saying um here's how to answer it. Like at the beginning of the plot, the car was traveling at a velocity of. Okay, so let's I'll help you with this. So at the beginning, I'm just trying to get to where we can. All right, at the beginning of the plot, the car was traveling at a velocity of what is the y value here?
It's 15.
15 meters per second. All right, now after blank seconds of constant velocity. So the car is at a constant velocity for how many seconds? What's the x value here?
For like, is it also 15?
The x value.
Oh, the X value. Okay, so it's going from 8 to 12 seconds.
Just the x value.
Uh, okay.
What's the x value right here?
Oh, it's 4. I'm sorry, 3. It's 3.
Okay, so
I was,
after 3 seconds of constant velocity, so um, the uh, car velocity changes from 15 meters per second to 0 meters per second. So that's what's going on here. It's going down 0 meters per second. In the next 5 seconds. Okay, so after 3 seconds, so that's here, the car's velocity changes from 15 meters per second. So it was 15, now it's 0 in the next 5 seconds. That's this line down here.
okay.
All right, now how is this what I'm showing down here from 8 to 13? How is that similar to the graph here from 0 to 3? What's similar about the graph?
Um, that they, I was about to say that the numbers are even numbers.
Talking about the actual blue line or purple line.
Oh, that they start off flat.
Flat, it's horizontal. So horizontal is constant velocity. So how many seconds is it at constant velocity down here?
0?
So let me try to we'll go back and look. It says after 3 seconds of constant velocity, 0 to 3 was 3 seconds of constant velocity.
Mm-hmm.
How many seconds of constant velocity is it down here?
It says 12.
That means 12 means 0 to 12. That's not how long. How wide is this part of the graph?
I'm overthinking this and I know that now. But not that wide. It's quite short. So, but
we can be more specific. It's telling you it starts at 8 and it ends at 13. So how much time is between 8 and 13?
5.
Okay, so after 5 seconds of constant velocity, okay, the car's velocity changes from, so we're gonna add this in, the car's velocity changes from 0 meters per second to, what is its velocity up here, right where this little dot that I put it? What's the velocity right there? What's the y value?
The y value is 20.
Okay. Now, how much time did it take to go from this red dot, which I'm putting down here, the red dot to the purple dot up there? How much time elapsed?
That's about also 5 seconds.
What's the starting time? What's the ending time?
Oh wait, hold on. It starts at 13, it ends at 20. That's like a good old 7 seconds.
20 is over here. That's just where the dot is.
Everything's complicated. I don't like science anymore.
You're just counting or subtracting.
Okay. That's one. Hang on.
This is 13. What is the x value here?
I thought it would also be 20, but I guess not.
20 is right here. That's
Yeah.
this dot here. I'm not asking about that dot. I'm asking about the one right there where the arrow is.
Yeah, that's what I assumed was 20 until you told me it wasn't. Um, okay. Oh my God, it's 17, isn't it?
Yes. Okay, so how much time has elapsed from when it started to when it ended?
4 seconds.
Okay. All right. Now, what is going on in this position here from 17 to 20 seconds? What's
Um,
the wording that we used previously?
Velocity?
It's all velocity. So you gotta be more specific. Look back at the first 3 seconds or these
Oh, you
five
said,
seconds
oh,
here,
we said
4 seconds.
horizontal. We
We
said
said
it
that
was,
we didn't write that because that's not exactly the wording that they want. Just got to look back in here, like
yeah,
what's
I'm
going
just
on the first
gonna,
3 seconds.
let's just read the sentences. Well, instead of saying it goes like, we just mentioned that there's a constant velocity, it
There you
changes
go.
from
That's
0
that's it.
meters.
That's it.
Oh,
So
there we go.
constant velocity. The car has constant velocity for the last 3 seconds. Okay. So the next questions actually look like they'll go pretty quick. Um, what is the initial velocity of the car? What is its velocity at time 0?
It's 15, but like you said, times 0, so it's 0.
It's 15. Its velocity is 15 meters per second at time 0.
Okay. 15 meters per second. And how many seconds does the car travel at? We already said 15 minutes per second, so I guess are we
So yeah, it says how many seconds does the car travel at this velocity? How far is it traveling? 15. How long is it traveling at 15 meters per second?
we said it travels about like 3 seconds.
Yes.
Yeah. So 3
All right.
seconds.
Now, to find the distance the car travels, you're going to find the area of this rectangle in red. You remember how to find the area of a rectangle?
Isn't it the, like length times width?
Yes.
Okay.
So 3 and 15.
That's 45.
Okay, so it travels, and I don't know if we need to show work, but we will. So we'll go distance equals 3 times 15, which is 45 meters. All right, what is the final velocity of the car? So it's asking about up here. What is the final velocity of the car?
It said the final velocity was 20 seconds.
20 meters per second. Good.
And what else do we got to say? We already said 20 meters per second, then I don't know what
That's good enough. Yeah, it's good enough here. So it says during what section of the plot start and stop times does the car accelerate? So it's accelerating under the following conditions when the slope is positive or negative. So let's
it's
look at
I was gonna say the accelerating slope is positive. The first
it could
one
also be negative.
is yeah.
So
The
so
first
look at
one
this.
goes
Is
is
the slope
negative
here
in this
is the slope here positive or negative?
positive.
So positive slope goes up into the right, negative slope goes down into the right. Is the slope here positive or negative?
Neither, it's
There
neutral.
you go. Good. So there is no slope there. All right, but what's going on here? Is the slope positive or negative?
Negative, it's going down.
Okay, and then here, what's the slope?
Positive.
So it's accelerating in those two situations. So you can say, so give me the start and the stop time of the first acceleration. What's the seconds that it starts at? The
The starting point is neutral.
Nope. I'm
Oh,
asking about the yellow here. What's the
the
start time?
start. Oh, well, the start time's at 15, but that's not obviously that's not the number.
Time is down here. Time is down here. I'm asking for the
It
X
starts at
value.
3 seconds.
There you go. And when does it stop accelerating?
Stops at 8.
Okay, and then it starts again at
13.
very good, and then stops at
17.
good. All right. What is the velocity before the acceleration? So that I believe it's referring to this right here. What's its velocity?
What is its velocity before acceleration? It was at 15.
15. All right. What is the velocity after the acceleration?
Well,
It's
I don't even.
we'll call it 0. Oh, you know what? You know what? This is a little deceptive. So this right here is referring just to the one that goes up and to the right. Now I see what they're doing. Now we can do this. All right, so let's do this differently. Give me the velocity down here.
13.
Down here. What's the velocity?
Oh, I said 13. Is that not right?
13
Oh,
is the time.
oh, sorry, it's 0.
0. And then after the acceleration, what's the velocity?
17?
What's the velocity?
Oh, right,
Velocity
20.
is the y value, 20. Okay, now the acceleration is the final velocity minus the initial velocity divided by the time. So we said that 4 seconds elapsed. Could you calculate that for us, please?
Yeah, sure. The answer is 5.
5 meters per second squared. All right. Hey, good job. This is definitely tough. What we're doing here.
It was
So
tough.
let me go ahead and save this file that we've got them, and then we will pick up here tomorrow if you want. We got 10 a.m. and 11 a.m. But that is going to do it for us, Ivana. So I will see you then. Hope you have a great rest of your day, and I'll see you in the morning.
See you in the morning. I forgot
All
that
right.
I was meeting with you in the morning tomorrow.
10 and 11. All right, it's not 9.
Thank God.
All right, I'll see you then.